much. I'm Zain Malik. I'm a software engineer at Chipset. And I have been working in period to work joining Chipset. I've been working on the different companies, basically heavily using the NoSQL databases, heavily using the big data. But right now, my main field of interest is the distributed systems. So it first started with the distributed databases, Cassandra, Elasticsearch, and right now I've been working with Kubernetes, Mesos, and it has been a year and a half with this. So I'm a developer. I'm not an operator guy, so have been coming through a Java background, and now I'm developing purely in Go, actually, during the last time. So let's go. So in Chipset, I'm working for the CRE team. It's the common runtime environment. So what we are doing in the CRE team in the Chipset is handling the Kubernetes, Mesos, and Hadoop cluster. I'm not going to brag about the containers that we are running there or anything like that, but basically, all three are using the production workload. And just fact is Kubernetes is gaining quite much traction lately, so we are moving towards Kubernetes, but we have a logical division between the cluster that all the jobs are going to the Mesos cluster, and all the services are going to Kubernetes. OK, so from today's talk, I'm going to talk about the love-hate relationship with the Mesos frameworks. The point to note is I'm not talking about Mesos. I'm talking about Mesos frameworks because it's different. I will explain about it. And maybe it's not hate because it's a bit harsh to say hate word, but it's a complicated relationship. And it has been hard how to manage with the frameworks. So I will explain about our experience, what we have seen in Chipset with the Mesos frameworks. I don't know if anybody knows about Mesos or Mesos frameworks or the cluster orchestration. So I will just I will start explaining what is the cluster orchestration, what is Mesos frameworks, and then I just want to put you guys on the point that you can just do the same analysis as me and do your judgments. I'm not going to take any conclusion from this. So let's do. So what is Mesos? So first we will do the official definition. That is the Mesos is a multi-user cluster management system with the expectation of a single Mesos cluster managing the resources of an organization, and blah, 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 blah. This is you go on Confluence, you put on your page, this is what is Mesos you're supposed to do. This can you just copy-paste, remove the word Mesos, put Kubernetes. It will be same. It will work everywhere. But now, if some friend asks me, hey, what is Mesos doing? I want to start using Mesos. So actually, it's you got a pool of resources, like a servers, and you want to just run containers over it. And maybe you don't even want to know where it's running because, OK, you don't care, actually. So for me, it's something it's a guy that's, I'm just running containers everywhere, in several different agents and different servers. And this is sounds really good. It's really good. But the thing is people are watching this and hey, they want to move all their workload to the Kubernetes Mesos, but it's a bit complicated. It's you're not talking to Mesos. So it's Mesos actually Drake. You know the singer Drake. If you want to talk with him, you cannot talk with him. You have to talk with his agent. Maybe you are Nicki Minaj and you have a direct connect and you can talk with him. But normally you will talk with his agency and you will register a concert or whatever like that. So same with the Mesos. You don't actually talk with Mesos. You want to run a container, you have to talk its frameworks. So why this coming like that? This is I want to explain a bit the two-level scheduling. So Mesos is actually a really modern scheduler. It's based on the two-level scheduling. And this is the reason the Mesos only deal with one level of scheduling, and there's another level that is only deal by the frameworks of the Mesos. So let's go. Let's start with this, and I will explain a bit about. So what is the first level? Scheduling of resources. What is resources? Resources can be stock, money, everything, but in this context, it's just the computing resources. I have a pool of resources, CPU, memory, disk, imagine network, GPU, any new resources that you can imagine. It's the computing resources that will be my pool of resources. And then you have a pool of resources, and you want to give it away. You are feeling really generous, and you want to give it away. But you will have candidates. You are a scheduler, and you want to give some part of that to one candidate or another candidate. So in this context, it's you're giving away CPU and the resources, GPU, and you're making a decision to which to give away. And this is the first level of scheduling in the Mesos. what is happening. You have a resources and you're deciding between different candidates. But yeah, you don't have candidates. You have actually, here you have the framework. Different frameworks, and you're deciding between like different framework, what to give, which framework. And what are you are like actually basically designing the resources, to be honest, like just memory and CPU. Some people will have also add this, but on the Mesos, normally it's just happening on the level of the CPU and the atomic unit of a resource that you offer to a Mesos framework is called an offer. So you are making an offer. You are doing an offer to the frameworks, and they can accept it or they cannot. They can decline it, like, I don't want, sorry. But actually, the offer is like all the resources that are available on a Mesos agent, okay? So you give it all, hey, I have 3 CPUs, 16 GBs, you want anything? And maybe he'll say, yeah, maybe I want. I will come back to this. But yeah, I just introduced a new concept here, like framework. So what is framework? Like, what is doing here the framework? So to talk about Mesos frameworks, I have already shifted to another level. That is the second level of scheduling. Okay. So yeah, this is what is the framework does is deciding what to do with these offers, what to run on this offer, where to run, and this is like deciding the destination of these resources. So it's like a framework can accept the offer or decline the offer. Okay, so it can just accept some part of it, and it will tell him what to do and what not to do with it. And it's just the part of framework. It's totally another level. And so right now we have talked about the 2 levels, like it's Mesos Scheduler and the Mesos framework. So and they have owned their roles inside the Mesos ecosystem. And the first level is the Mesos Scheduler, and the second level is Mesos frameworks. It might seem reverse, but it's not. First, you are deciding the destination of the resources. So better, like to be politically correct, is Mesos master on the first level and the Mesos frameworks on the second level. So now I have explained a lot of theory. I will just explain like how is to actually for a task to live in a 2-level scheduler. It's the Mesos, but it can apply to any 2-level scheduling. So I have like, imagine I want to run a task. You know, it can be anything actually. It can be a REST API. It can be my batch job, a hello world, or anything you can imagine that can be fit inside a container. Okay. So now I want to run it, and let's say I want to run a busybox. I need 1 CPU because you have to decide what resources you are going to assign to this container and how much memory you need for it. And for example, I'm going to run a really stupid job, but it's like, it will echo hello world, maybe it will sleep infinitely, and that's it. I want to run it. And I want to run in Mesos. So as I said, you cannot talk to Mesos. You are talking to a framework, and you will tell to the framework, hey, I want to run this job there. And the frameworks internally, like the framework internally will have some kind of queue, maybe some implementation. It's really open implementation, and they will like tell like, okay, they will save it for it. But on the other side, like it's happening is on the other side is happening is the Mesos master is doing the offers to the framework, okay? So Mesos framework is receiving the offers, like how much resources can use, and it's receiving continuously different offers. And on the time that you ask him, hey, I want to run some tasks, they will start doing, okay, yeah. They will accept part offer because they need resources. They will accept part of the offer, and what to do with the resources, they will tell, hey, actually I have a task. I want to accept a part of your offer. I want to run a busybox, but I would need only just 1 CPU and 256 megabytes for that. And what you have to do with this container, and decline the rest offer. The rest of the offer will go to another framework maybe, or we will come back to you. Once Mesos master know that, okay, yeah, a framework has told me like, okay, has accepted my offer finally, what the Mesos framework is doing, Mesos master is doing is tell to a Mesos agent, like, hey, run this task, okay? And it will tell to the Mesos agent, like, you have to run this task. Mesos agent is the nodes, the servers that you have that form part, that make your big cluster. The thing is, like, here I'm going to skip the part of the logic that is like the executors. The executor is like, you know, you have like in every Mesos framework, you have an executor that is deciding what to do with each task. So right now, like, for example, the default executor is the Docker. It knows what to do with the Docker. It understands the executor is like, if you're passing a Docker image, it knows what to do with it. But for example, if you want a framework that is using a different executor, you have a Java binary, and you can just code your own executor, and it will know what to do with this stuff, okay? It will download from where it has to download, from some Docker Hub or maybe some other place, and you can do it. But it's not important for this talk, okay? But just keep in mind, I don't want to skip that part. So let's dig a bit more inside, because it's important to go inside it, like what is happening in the first level scheduling and where the Mesos is offering. It's not like a random thing that is happening. It's like, no, it's not like a by order, like, okay, yeah, I give the offer to that or that. It has to decide on some kind of logic. And actually, this is the part where I was saying that Mesos master is offering to one framework or another. And the Mesos implementation is based on a paper that is called DRF, Dominant Resource Fairness Algorithm. It was released by Twitter. Some guys working there. And it's basically the default implementation that's still using the Mesos. That is deciding the destination of each offer. How it is working, actually, the DRF is like, it's a modern scheduling algorithm. It's really hard to put in just one sentence to explain it really easily, but I will give it a try. So it's like the framework that has the least share in the cluster will first get the offer. So imagine you have different candidates, and the most poor one, that is not getting any offer, that is like really poor. So it's a fairness algorithm. It will try to give you offer, hey, you need something, and if he needs, he will get it. But the people who are like the big guys of the cluster that are dominating the cluster will get it later. So the example will be better. So for example, let's imagine we have 3 frameworks, and one framework is like having the 40% of the share of the cluster. The other is having 5%, and the third framework is like 10%. What the DRF will do is like reorder them. Like it's just rank them like by their capacity usage. And it will rank them, and the first one will be with the least users, so like ascending order, and it will offer the framework to, hey, you need this offer, and it will offer to the next and next. And these kind of the DRF, like the Mesos implementing, is called concurrent pessimistic. What it means, like I can offer in parallel different offers to different frameworks. Okay, so I can do in concurrent offers to like my first framework, second framework, but each offer will be at max for one framework. So it's pessimistic because maybe they don't need it. There's another approach that is optimistic, that the one offer you give to everybody, and maybe somebody takes it, and it's like a jungle. You fight it, and if you get it, it's okay. Other will fail. And the old one, like this is like the approach is like working quite fine for it. But the thing is, like over the time, the Mesos has been implementing a lot of features over it. So you will have now roles of framework. You have now the quotas of framework. In the last version, they had the fault domains that is also deciding where to give the resources. So it's not that simple. And if you go to the documentation of the Mesos, they will say, OK, yeah, you can actually override it. You can write your own allocation. You can give it only to your favorite framework, always, no matter what happens. Or maybe you can do random. It's up to you. But the thing is, like, to do that, you just need to know a bit of C++, recompile Mesos, and it's up. But you have to take care of not losing any feature that Mesos has introduced lately on it, because it can be messy. You can have a resource starvation, and it can turn a really bad place. OK. So the second level of scheduling. So what is the second level of scheduling? Is the frameworks that are deciding what to run on those tasks. So how they are deciding on it, how they are like taking decision on which task to run on it. And actually, there is no rule. There's nobody's like imposing you which to decide. You can take it for your own. But I have looked on the code for Marathon, Kronos, Aurora, and all these frameworks and Titus. They are all doing the same thing, that is the greedy algorithm. It's like I have offers, and we need to run tasks. The first match, that's it, and it's OK. They're not like blocking it. They're not taking any provision. And actually, this is what they are supposed to do, because the two-level scheduling is supposed that the Mesos is taking care of the resources, and you are actually just focusing on the features, and you don't have to do anything else. And moreover, you cannot do much stuff there, because if you don't have the whole picture, you have just part of the offer. You have one offer, maybe the other cluster, you don't have any picture what is happening there. So what you can do is like solve the problem locally, and that's using the greedy algorithm. So yeah, the frameworks deciding are like which tasks to run on it, and there's like I have been doing maybe the cook scheduler, that's framework that they are being a bit smart there, but the rest of them, all of them, it's like just run it. But that's actually the thing. The Mesos has to abstract the resource scheduling problems, and the frameworks can then focus on scheduling tasks. And they don't have to be worried about and that's actually why Mesos works so good, because you are actually doing application over it. You can make distributed applications. You don't have to deal with which offer is coming, which is not coming. Mesos doing it really good. And Mesos is like the good guy, this good boss. Everything is good. Yeah, cluster is burning, but the frameworks will receive it, the offers, whatever they want, and he will deal with all the problems, happy face always, and you get through it. You are running containers. Maybe you won't get any offer. Something is wrong, but you won't know. You will, OK, yeah, I'm waiting for Mesos to give me some offer. You don't know the cluster is burning, everything is down, but yeah, it's OK. But because it's the responsibility of the Mesos master to take care of it and not of the frameworks, so this abstraction is like helping any misbehaviors in the cluster to take them any help. OK, so now I have explained all this is to explain that, yeah, Mesos has done really a good work. And so they have done the two-level scheduling. Nobody else is doing two-level scheduling. Kubernetes is doing monolithic scheduling. Yarn is doing monolithic scheduling. And the Mesos is the only one that is doing. And people are really taking good of it. But now we have done this like that. And you have said, OK, yeah, the frameworks part, I don't want to take care of it. You do it however you want. Maybe Mesosphere is taking care of Marathon. Kronos, yeah, goodbye. But I don't want to. The others are doing every. And there's some small life frameworks that are coming and going. So now let's forward in a few years. It happened already 4 years ago. This was happening. And now we have an amazing system that can scheduling, that can scale, that can thousands of containers. But now let's add features to this. Okay, so this is we want to run a task. And I want to add a feature because, things change, you have new requirements, and their new stuff is coming. You want to integrate with another application. You want to integrate with your CDCI. You want to integrate with your logging, a lot of stuff, monitoring, metrics. Thing is, for example, I'm going to put the examples of real what happened. People wanted it to do it, and what happened in real. So there was a real demand for doing labels. Labels is people wanted to actually tag their tasks. I'm running my task, I want to tag it. So later when it's running in the Mesos, I know where it is. And this can be used as to doing load balancing. You want to find your task, you have to service discovery. A lot of use cases are actually depends on labels. They're how you can do it. Okay, I'm a framework, I want to do it. Tell me how I can do it. So you have only one way at that time, because Mesos doesn't support labels. Mesos is not saving that information. So you start saving another state of the cluster somewhere else in parallel to Mesos, maybe in Zookeeper also, but somewhere else, and it's doing it. But it's a really bad idea. Don't do it. Okay, don't even think about it, because you are maintaining two states. And OK, Mesos was OK, yeah, many people want it. Let's do it. Let's do it. Because Mesos have a really brilliant team, and they did it. They did it in the version 0.22 in the March 2015. So yeah, but the thing is they added it to Mesos, but doesn't mean that you can actually use it. You have to implement it in your own framework if you're using in-house framework, or you have to implement it in do the pull request to the Marathon or Kronos. The thing is it can take, it's not the two levels scheduling, it's it take much more time. So just the case of the labels, it was added into the Marathon in November 2016. Just maybe a year and a half. And so a year and a half before, you weren't able to do any load balancing. You won't be able to add any labels. And it's pretty modern. And that was taking a time. In Kronos, they are not maintaining. So even if you want to open a pull request, it won't happen. You cannot do that. So it's you have to find another framework or build your own. The thing is but this is a bad example, because this is not happening always. So I would be lying with every feature this is happening, complaining. But this depends on the hype of the feature, So for example, if we have a feature hey, I want GPU. Yeah, oh my God. Everybody will open pull request. They will take care of it, because part of it is because the data structure of the resource is already defined. Where is CPU? You have to put a comma and another GPU, and that's it. And moreover, also the hype. I want to run TensorFlow. I want to do that. I need GPUs. I cannot live without it. Many people saying, and they would just open the pull request, and it was magic. It was released in July, and in September it was in Marathon, and by September it was in all major frameworks of the Mesos that were active. And for example, there is the cook that is like that's a really cool scheduler, but and they also added in August. So what I want to say is they added pretty quickly because depend on the hype. So yeah, it's depend. So you want to do development over Mesos. Now you are depending not only two-level scheduling, you are depending on anything else. You have to wait for add features. You know, this is a blocking. Now I will give the last example, and that's it. I will stop it. That is the maintenance primitives. Okay, this was the battle of the shipster in the summer 2017. We wanted to add it. So the thing is, like, it was added. The feature was added in October 2016 to the Mesos. What is this feature? Okay, this feature is like you can put your nodes in maintenance. Okay, any agent that is going to be shut down, terminate. You are doing, for example, our use case was auto scaling. We are going up and down in the cluster depending on the usage. But what happens to the tasks that are running in that agent? You know, they keep running. You will kill them, you will lose them. And what happens till the moment of the terminate or till the moment of you are going to disconnect it, the Marathon, Kronos, everybody's still scheduling tasks inside it. Okay? This is really a bad use case. Okay, we were living with this that, okay, we cannot do much about it. But we dedicated 2 sprints to this, and we were like, yeah, we want to fix this, but because we want to give to developers of Shipster and everybody else that is using our system, that there's no jobs that are failing due to this, jobs lost or whatever. I opened the pull request to Kronos. It's still open. We are using a patched version of Kronos that is supporting this already. I opened the pull request to Arithmetic framework that is like run once task scheduler of the Mesos. Is pretty cool. They accepted it. And my colleague, Alan, he's not here, but he opened a pull request to Marathon. Okay, it was like maybe 7 months ago. They accepted the pull request after many comments, and then but it's in the master now. But there's no version of Marathon released with this version. So maybe you have to still wait for it in the next release, and you will start using it. But you can compile the master branch, and you will start using this maintenance parameter. You have to enable it. For sure, we are using the patch version already in our production. So this is kind of stories that I wanted to tell what was happening. That was really beautiful story of the Mesos, that 2-level scheduling, and you can take care of one level, frameworks are taking care of other level, and that's it. But what is happening is that there is nothing wrong with that. Actually, it's OK. We can live with it. It's OK. But what is happening is like not there's only 2-level scheduling. There's 2 levels of development cycles. So you want any feature to add any feature, or you can do a hacky solution, you maintain state somewhere else, you patch over it, and then you can use your Python script somewhere, you install daemons in every, you bake the AMI, and you run your Mesos agent that have another thing, but that's not Mesos cluster. That's something else. That's like, like on steroids, your cluster management system that is not open source. And for example, the best example of this solution is the Pasta, is by Yelp. You have to install your Pasta agents on all nodes, and it has a lot of features, but it's actually hijacking the spirit of what was Mesos. So there are frameworks that are like doing releases a bit late with the Mesos releases. They are adding feature, but then you will start using frameworks that have a really short life cycle because somebody was so inspired some Friday night, and they just started doing the framework, and it's really cool, but actually they have moved on, and the framework is there. But you saw it, and it's actually for your use case, and you're like, OK, it's in GitHub. For sure, I will start using it. But it's stuck there. It's not active anymore, and you will start using, and then you are like, OK, now I want to use labels. OK, yeah, this framework is using it, but this one framework is not using. So you have to get your hands dirty and do the pull request, make your contribute. But for sure, there are other frameworks that can really following along all the Mesos development, that is like Cook or other frameworks. But yeah, they are controlled by some other companies. They have their own use cases. They will control the development. They will accept the feature. You have to discuss on the GitHub issues, and then it will go ahead. So, but what happens with Mesos is also that it has not stopped adding features. They have not stopped from a long, long time. I use this graph to show like how Mesos is going on. They are just adding features from the version 0, and they're not stopping. And the number of to-dos in the Mesos code is ever increasing. And they are taking a lot of cool features that are really cool, but actually To use them, you have to dedicate your hours to them, okay? And you have to maybe do some kind of development, do some kind of patch, and then maybe later you can use it. It's not just as, like if you see a Mesos release, hey, changelog, there's some new feature, I'm going to use it. Take care of what you're saying, because maybe you have to do something, and Mesos is just providing an interface that you have to later develop on it. So running a container in Mesos is just the start. It's not the end. You read a Medium blog, and it's like how to run a container on Marathon Kronos. OK, yeah, this is really just the start. This is not the end. This is the start of the adventure. And this is not going to be, but it applies the same for the Docker run. Do a Docker run or the Kubernetes pod. This kind of stuff is just the start. And it's not like the end of the feature. It's not going to solve your problems. And this is really wrong image that people are getting, that you have to just running on the Marathon and it's working on production. If we have it in production, that's it. No. The thing is, like, any integration that you are going to do over the, any integration is just limited to one framework of Mesos. So any integration, you integrate your Travis with the Marathon, for example. Yeah, it's with Marathon. It's not with Mesos. You want to integrate your Travis with Kronos, so do another integration. You have integrated your Spinnaker with Marathon, so it's with Marathon. Or you have integrated your job solution, batch job solution, that is with Kronos, it's with Kronos. It's not with Marathon. So any integration, any development you are doing, you are talking with one framework. And the fields of frameworks is like open, totally open. You can do whatever you want, open API. API of Kronos has nothing to do with the Marathon. There's no control-guided framework that is like, you can say this framework is the victorious, because no, this is not the true. Marathon is leading it, but it still lacks a lot of features that you want to do that you cannot do on that. So here comes the question, so which framework should I choose? It's actually depend on the use case. Don't treat the Mesos cluster as a cluster container orchestration tool. It's just it's a business case. You have to find your business case, and what you want to do. You want to do batch jobs, so just be clear. You want to run a batch job on Kronos, install Kronos, but beware of the limitations. Yeah, and it's really hard. I know it's pretty hard that to know which framework you want to do, because you have no idea. There's a lot Marathon, Aurora, and then Kronos has their stuff, and everybody has using their use cases. In Marathon, you cannot do the cron jobs. In Kronos, you cannot do services. So everybody is like their services, and you have to install one or two frameworks to cover all your cases in your company. So after while we were running in the Shipster with the Marathon and Kronos, oops, yeah, okay, it's fine. So what you should expect when running inside the cluster. It's not anymore like I want to run a container that is on my Docker, and I just want to run it. Now you should expect more things. What we were saying, people want to do CDCI. They want to do multi-tenancy. There are different teams, and they don't want to see the resources of other people. They want to do SDN. They want to create their networks. They want to secure these networks. They want to do logging. They want to know where their tasks are logging. They don't want to use the Mesos UI to see the logs of the last 20 execution. They want a centralized place where they can see it, the logs of their job, what was happening of their service when things go wrong. They want monitoring. They want to do, if something goes wrong, they want to get the alert. So everything, and most important, is the UI case. UI case is not the user experience it's not the UI. UI case is all the onboarding experience that a developer gets, he wants to do on the cluster. I'm a developer, I'm developing my application, and now I want to onboard on your cluster. Now the reason of the money that it will be cheap or whatever is not true anymore. Because if the developer has to dedicate a lot of hours to figure out how to do logging, how to do monitoring, how to do their networking, how to do the multi-tenancy, how to save their application, the hours they have dedicated, it's more expensive than maybe they just spin on a instance in the Amazon, and they can run their application there. And because they know how to do it, they control everything. So you have to offer a complete solution before going through, saying, hey, yeah, now you can run a container. It's fine. It's your container, and that's it, because that's not true. So the things with what we were seeing in the Shipster were OK, yeah, that the Mesos and the developers and operator are really good friends. Mesos hey, don't worry, I take care of this. It's fine. Yeah, everything is fine till you have new requirements. They come from anywhere, and they just kill your setup, and you are just finding out again, OK, how to fix that. You are doing going across another hacky solution, a patch, fix, that could be like 1 month to fix it, and it's like already blocking part of your development. But you thought that it was all controlled, that Mesos is going to help you, but that's not true. So going to like start getting a conclusion, like I would say like Mesos is for brave people, really. Like who are ready for challenges, you know? And before getting on Mesos, like start getting with, you have to get ready to get your hand dirty. You know, you have to know what to do with what is best framework. You have to read the code of that framework. You have to know how to do patches on frameworks. You have to do pull requests to them. And you have to make it clear it's not like a general purpose orchestration tool, because you won't be able to do it. You can do a meta framework, that will come later. So the thing is, like, what the conclusion that I have taken is like, it's get ready to read code of Mesos frameworks, okay? The best framework that the chipset is running that I have no problem is like an in-house developed framework. But the thing is, it was not a cluster orchestration tool. It's an application. It's a fraud detection application that some guys in Paris developed it, and it has given 0 problems to us, because they are just developing, covering a business case, and they develop a distributed application over Mesos, and that was a framework. They cannot, and they're controlling all aspects of it. And this is the best use case that I have seen, because there were like 0 problem in them. They have never been like down, maybe down for some time for our fault, but there had been not so problem, and they can quickly do any patches they want to do with their frameworks, and they control the code. They know where to do those changes. So yeah, the point was like it's really good for doing distributed application, but not as a container orchestration tool. And yeah, this is like, OK, then there's another approach that many people are taking. So who's like people who for sure running Mesos in production, they will say, no, that's not true. Yeah, there's another. The other approach I call the heroic approach. This is for heroes, you know. And this is like, you can do it when you are in a big company like Netflix or Apple. So Netflix have a Titus, Apple has Jarvis. So what is this heroic approach? Like you just limit to get your solution to one framework. You choose that framework, or that framework chooses you, like, I don't know. But yeah, you just dedicate all your life, all your resources to that frameworks, and you just start developing around it, like Marathon or maybe like any kind of stuff. So it actually starts with the question I was asking, which framework should I choose, you know? So you just choose one, but that's a really heroic approach. And then you have, for example, imagine you have a framework, and you have choose one. You have, maybe it's in-house. You have developing one, and you start doing it. And what is happening that you have resources there, and one framework, all the offers will go to one framework. He's not competing with anybody else. And what the framework is doing is like holding all the offers. What that means, that frameworks say, hey, you want that offer? And the framework is like silent. It doesn't say anything, like not declining, not accepting, like, yeah, I'm busy, you know. And Mesos cannot give that offer to anybody else, because he has not got any response from it. Like Mesos, like, what the hell is happening here? But yeah, the thing is, you keep all the offer that is coming from, yeah, give me, I will decide later. Then you have a task to be scheduled. You have a one queue, you know. And you can match all the offers. You have all the resources of the cluster in one place inside your framework, and you get for the best match for the task. You know, you can do bin packing. You can think about advanced solutions. You can do any kind of. You can even think about saving another state of the cluster somewhere else, because you're adding features on it, but because there's only one framework that is running on your cluster. And this is this makes the thing that the Mesos master and the frameworks are actually working together. It's like one entity. They cannot work different. Like they are just encapsulated into one piece. Who is doing this? Aurora and Titus are actually doing this. They are doing this because of one library that is called Renzo. Renzo is like, maybe people know about it. I will explain a bit about Renzo. Renzo is a library that you add to your framework, and it does what I said before. It just holds the offer and decide for the bin packing, and decide the best decision for you. And it will do the optimization for you, and the Aurora and Titus are already integrated. So you can configure it for good or bad, the Renzo library. But the thing is, this is the point that when we were doing a RFC for chipset, we were like, OK, we want to do like the heroic approach. Let's think about it, stuff like that. And we gathered all the requirements. We gathered like what is use cases of a developer, of users, business use cases, and we will go for this heroic approach. But at that point, we just step back. We're like, OK, what we're doing actually? Like, see the bigger picture. The bigger picture is like actually you're doing the monolithic scheduling. There's no two-level scheduler, Aki. There's monolithic scheduler here. And the thing is like you are just making your two-level scheduler to rest, and you are doing the one-level scheduling. All the offers that are coming, you will decide on them. There's one level. And you know who is doing the monolithic scheduling? Like this, the same thing? Kubernetes. Yeah, you have a Kubernetes scheduler, and you match for the best port. Like Kubernetes, how it's doing is I get all the resources I have all the resources, and I rank all the nodes that are my resources. And I rank, and the best ranked get that port matched. And I'm doing it for the next one. I'm doing it one by one. I'm not doing it concurrent. There's no two-level scheduling. And this is like you have to step back and know what you are doing with your Mesos. Don't kill the soul of Mesos of two-level scheduling. Just think about it like maybe at some point it's better to step back and see the whole picture, what is happening inside it. So what are the lessons learned here? Like just to wind up everything, like the Mesos frameworks are really disruptive. You want to do an application, it really helps you to start with it. If you don't have to take care about if it's a distributed application or not, and it's really easy to make them. Otherwise, moreover, you don't want to deal with zookeeper and leader election and other kind of stuff that can get really messy. Mesos help you, and you build a framework, and it's easy. So that's and moreover, you have to select about your use cases. Your business use cases really clearly. And one thing is clear, the Mesos scheduling of resources is flawless. So I've done a bit maybe controvert kind of thing. This is like when you select for frameworks, actually the Mesos is really, really, really good. You know, they do resource scheduling. Nobody else is doing the resource scheduling like Mesos done. But when you put some flaky frameworks over it, it just kills the solution. Nobody can see it. They are like, but yeah, I cannot do that. I cannot see logs. I cannot do that. Or I cannot do the monitoring and other things like that. And for sure, here the questions come like, so how I would picture in this like the Kubernetes. So basically, Kubernetes is not so good in the scheduling. For sure, it's enough. If it worked for Google, it has to be good. But it's like, like this. So it's like, it's not maybe the best one in the market in the scheduling, but the front is really good. They give you a batteries included solution. You have the kubectl. It's like really the game changer for developers. They can see their logs, they can see their ports, and things like that. And every feature that you are adding in every version of Kubernetes is included fully. You have to enable the feature, and you are able to use. You don't have to code. You don't have to enable it for your scheduler framework. And this makes it a really game changer because the time to deliver reduced drastically. Okay? So if there's some feature or something that you are lacking, you do a pull request to Kubernetes, or you just open an issue. And the community is so big, you just need to open an issue. Somebody will just take the issue, and they will do the implementation. And turns out to be pretty easy for the UX side. It's pretty easy to do any kind of decision on that sense. So I'm not going to discuss if Mesos Scheduler is really good, because that's true. It's a two-level scheduling. It's doing on the back. But depending on the framework you choose, it can be really bad taste for the people who are like using actually your cluster. So to end up all the presentation, I would say like, no matter, like, this is with the DevOps culture and everything like that, no matter what choice you make, but you have to improvise, adopt, and overcome to the new solutions, to new conditions. And it's not about Mesos, it's about not Kubernetes. You have to read the code. Whatever you're doing, get your hand dirty, and do the pull requests, do the open source contributions, and you will live really good with this solution. And people will live really good with the Mesos cluster, and people will really be happy with the Kubernetes. But the thing is, you have to move a bit. Otherwise, it's like that. So yeah, I think I'm hopefully show you my perspective. So I will just finish the presentation here. Thank you. So if somebody has any questions or something like that, you can ask me. Later, I'll be at the stand of Shipster. You can come for me later also in the presentation here. Thank you. Okay, yeah.
Hello.
Hi.
Thank you, mate, for your talk. I do have actually a question about the infrastructure behind your Mesos cluster setup. Is that something that you can elaborate a bit?
Yeah, for sure. Because the thing is, like, when I was preparing this talk, I had like 2 or 3 demos also prepared, but when I see like there was only one track, I just deleted from my presentation. I turned it to more high level. So infrastructure, you mean where it's running, right?
Yeah.
Yeah, exactly. So we have like, actually all the 3 clusters, Mesos, Kubernetes, and Hadoop, are like automated infrastructure. So we are running all 3 on Amazon.
On AWS, yeah?
Yeah, and we are using the cloud formations to build our cluster. So it's like immutable infrastructure at any point. So if our Mesos clusters goes down, we can just run up a pipeline spinnaker and stuff.
Sure. And in terms of sizing of those machines?
Oh, yeah, for sure. The thing is, like, it's auto-scaling all the time. So we have the instance. I don't know if I can tell you this here. It's a secret.
That's why, yeah.
Yeah, I don't know.
Wait, I can gather you later.
Yeah, but it's, you can come to me later. But the thing is, like, at any point at Mesos, it's running like near 2,000 containers. I can give you average load is like, average load of each container is using like 16 gigabytes of memory and 2 CPUs. And for Kubernetes, we are rising. Last time I checked, at any point was running like 3,000 ports. And it's also increasing. But Kubernetes like increases much more than the Mesos.
Sure. The last one. Have you ever guys considered of using DCOS, for instance, and bringing all the infrastructure in-house?
Yeah, for sure.
So,
like
yeah.
we have alerted the DCOS. The problem with DCOS is like we are like a big enterprise, and we have our own identity, access, logging, and everything like that. DCOS is really good if you have like you're running a small company and you have a startup and everything is like within a team or 2. But when the things get out of control, for example, the in-house development frameworks, it's not available on DCS. You know, we need to set up like somehow. The code is not open source. So these kind of stuff make it hard to us to adopt for DCOS. Yep. Any other question?
Thank you for the talk. Do you have any tips on how to handle hardware failure? Like, what's the best way for Mesos? Because I assume it does not auto-restart everything.
Yeah. Okay, so hardware failure, like how you handle it. The thing is, like, for sure, you have to follow the best practices. Like, you cannot have, like, if your hardware failure is affecting your service, then you're doing it wrong. You should at least have 2 or 3 instances running on different, put like a unique host label on different instances, and you can avoid like this kind of hardware failures. But if you know that the hardware is going to fail, there are like 2 ways. The first way is like you do through maintenance primitives, like how we did at Chipster. Like we know that something is going to go down, for example, with spot instances and stuff, and you can already stop scheduling and drain the node. The other is there's a startup in Polonia, they are called Allegro, and they had this battle. They started doing custom executors. What is a custom executor? Everything that was running on their Mesos cluster, when they know that it's going to be going down, they just remove from their service discovery that instance. That's it. And this is like done on the node level and not on the upper level that you know where it's coming. So yeah, but I think the best way is like just tuning up the instances like 3 or 4, and if one goes down, it will, for example, Marathon does it really good.